Did you know your heart will beat around 2.5 billion times in your lifetime? That's not just keeping you alive, it's performing an intricate electrical dance that would put most power grids to shame.
Well, that's a mind blowing number when you really think about it. And what's even more incredible is how this complex system operates completely on autopilot.
Let me tell you about the true conductor of this cardiac orchestra, the SA node. It's this tiny cluster of cells that generates electrical impulses through something scientists actually named the funny current.
Hold up. They really called it the funny current? That seems pretty casual for something so crucial to our survival.
Oh, you know how scientists can be with their naming conventions? But this funny current is seriously sophisticated. It uses special proteins called HCN channels that carefully control the flow of sodium and potassium ions, kind of like filling up a bucket drop by drop until it overflows.
So, when this electrical charge hits that tipping point, that's what triggers each heartbeat?
Exactly right. And here's where it gets really interesting. The signal doesn't just blast through the heart all at once. Instead, it follows this precisely timed pathway through different specialized tissues, each playing their own crucial role.
Hmm, that makes me think about the AV node. Isn't that like some kind of electrical checkpoint?
More like the world's most sophisticated traffic control system. The AV node actually slows down the electrical signal for about zero point 0.1 seconds, which turns out to be absolutely essential for proper heart function.
But why would we want to slow down such an important signal? Wouldn't faster be better for pumping blood?
Well, here's the genius part. This brief pause gives the upper chambers just enough time to contract and push blood into the ventricles. Without this delay, the heart would be about 30% less efficient at pumping blood.
You know, it's starting to sound like a perfectly choreographed dance where every step has to happen in exactly the right sequence.
And just wait until you hear about the next part, the bundle of His and Purkinje fibers. These structures form what's essentially the heart's electrical superhighway system, capable of conducting signals at speeds up to 4 meters per second.
That's fast. How do these cardiac highways actually work?
So picture the bundle of His as this main interstate highway branching into thousands of smaller roads, the Purkinje fibers, that reach every part of the ventricles. These fibers contain about 40% more connexin proteins than regular heart muscle, making them incredible conductors of electricity.
Well, that's fascinating. And I've heard these fibers can actually generate their own electrical impulses if needed.
Exactly. It's like having multiple backup generators. If the SA node fails, the AV node can generate a rhythm of 40 to 60 beats per minute. If that fails too, the Purkinje fibers kick in at 20 to 40 beats per minute, just enough to keep you alive until help arrives.
The redundancy in this system is remarkable. Nature really thought of everything.
And here's something that'll blow your mind. This entire system is so sensitive that even a zero point 0.5 millimole change in blood potassium levels can dramatically affect how it functions. It's like trying to tune a radio to exactly the right frequency.
That explains why doctors are so careful with electrolyte levels in cardiac patients.
Absolutely right. And medications can have huge effects too. Some common heart medications can change conduction speeds by up to 50%. It's like fine tuning a complex electrical circuit where every adjustment has to be precise.
You know what really gets me? The fact that this incredible system is working inside all of us right now, beating away without any conscious effort.
And it adapts constantly to our needs. During exercise, it can increase output by up to 500%, pumping up to 30 liters of blood per minute. That's like going from a garden hose to a fire hose in seconds.
This conversation has completely changed how I think about my heartbeat. It's like having a tiny electrical power plant running inside us.
And just think, this system has to maintain this precise electrical choreography for an average of 80 years, adapting to everything from intense exercise to deep sleep, all while keeping that intricate dance going. It's truly one of nature's most remarkable achievements.